Today's lesson is I will be talking about the programmable logic controller. So this is just a diagram of the programmable logic controller. It includes the input and the central processing unit and the output. Input is connected to the switch. So this is open switch output, open switch close switch, as well as a timer. Output is connected to the relay, coil, and the light. So this is a overview diagram of the programmable logic controller. So the controller knows our processor and memory system and the power supply. So this is a overview of this power supply connected to the power supply, connected to the processor, and also memory. Because of the memories are also power supply connected to this memory. Because memories are record this any program and the data, and then these are interact with the processor. So this is a block diagram of the major CPU components.
Coffee is ready.
So this is a typical operations procedure of the PLC. So we scan the input is a scan. Input is connected to the sensor and it scan, and then also read the information, then execute and then write the information. So this is a input is a reading, second and then read the thing, then the execute is a processing and also write. So this is an illustration of the scan. So this is for the input and output interface of the programmable logic controller. Here we got the processor and power supply. So those are input module, then the output module. So input modules are the switch, various kind of the switch, normally open switch, normally closed switch. The output modules are connected to the lamp, resistor, also the light, relay coils. So this is the input output interface system of the programmable and logic controller. So input can be the discrete input, but if you connect the push button, so normally open or normally close, or the normally open switch, normally close switch, then we can provide the inputs and push button. So this is the discrete input. Analog input can also be because of the when the level transmitter connected, so that will be the PLC's analog input because of the when the flow level increase, so that they gradually sending the signal input. And also decreased input can also be this decreased output case. The output can be the light, so electrical current flow to the light, so output like this. So the analog output connected to the meter, or the analog output is connected to the analog to the digital to analog converter, and connected to the VAR. So this is the way of the analog output. So depending on the output, we can measure the output level, as well as we can also produce a signal. CPU is a central processing unit. It contains the system memory and also a decision-making unit. Central processing unit is include a microprocessor system memory, and a PLC decision-making unit. The CPU monitors the inputs and makes a decision based on the instruction held in the program memory. So the CPU performs the relay counting, timing, data comparison, and sequential operation. Those are the components of the CPU. So this is a CPU system. So this CPU is connected to the output system. So output connect relay also we connected like this. So the like other computerized devices, the CPU in a PLC. CPU is a brain of the PLC, so able to do the following information, following operations. So it can update the input output. So this machine allows the PLC to read the status of the input terminal and adjust or de-energize the output terminal. performing the logic and the arithmetic operation. So CPU conducts all the mathematical logic operation involving the PLC. Also, that it can communicate with the memory. So it can have the PLC program. Data are stored in the memory. So when the PLC operating, CPU read and change the context in the memory location. It can also scan the application program. This we call the data diagram. So this can allow the PLC to execute the application program as specified by the programmer. CPU control the supervise the operation within the PLC. It can carry out the program instruction stored in the memory. And the internet communication highway or bus system is carries the information to and from the CPU memory and input-output units under the CPU control. Those are the functions of the CPU in the programmable logic controller. So the programming language of the PLC, there are 3 programming languages. We use the ladder diagram, Boolean, algebra, and graphics system. So this is the kind of the programming language. Ladder diagram language means that we have to use a ladder diagram switch contact. So they will be normally open, normally closed. So those are normally open, normally closed are we arrange. So that we connected to the normally closed, normally open, connected to output coil as well as the process. We enter as an element. So in this case, the twos are output 10 and I01 is connected to the 2 output system and connected to the relay coil. Now 2 is also the cursor. So this is kind of the PLC output system. And operation means that both switch must be closed. It can happen as output. So this is how to write the thing. Is that you get a load, add a load. So I 0.0, A means N. I 0.1 equal to Q 0 by 0. So this is a letter diagram representation. The statement list representation. Also, that we can also utilize the block diagram. So the M gray here, I00 and I01, N and the output is Q00. So this is a letter diagram of representation and statement list representation and the function browser program representation. So the operation is either 1 or 2 is operate. The output will be operate. So this is a I02 and I03. Either I02 and I03 operate, then the output Q01 will operate. So how to write this statement list representation is network 1. In this case, load LD. So I0.2 O means all I0.3 equal Q0.1. So this is the way the lab. So the function block representation is I0.2, I0.3 or the Q0.1. So this is the letter diagram and the function block representation. So that this is what all the enable reset outputs are included. Times are enable time present are included. So enable reset, enable time reset function. So this is the input condition and the functional blocks are output condition of the programmable logic controller. So that we can write the things are run LD. So output is a percentage IH1 and MH5 and SD. So this is where the run. So letter operator operating and command. So the kind of this PLC command can be a sequence command. This is a basic command for the creating sequence logic circuit. Comparison command, application command to execute the comparison operation. Arithmetic commands are application command to execute the arithmetic operation. Logical operation commands are application commands to execute the logical operation. Rotate shift commands are application commands to rotate or shift data. Increasement and decreasement the application commands to add and subtract 1 to the data. Conversion commands are application commands to change the type of the data. Transfer commands are application command to copy, exchange, and transfer the data between the internet devices and timer counters are in command. Basic commands to use the timer counter and the jump internet command. So those are kind of the commands are included in the PLC system. So the application command to execute the internet call or the jump will be specified. In this case, you can see that at the line 0 and load and 0000, and then out is 0063 and also load not and 000 out are B064. So we can at the line 0, we have to load the and 0000. Then output is at B0063. The next one is a load knot. This is a knot. Normally open. Normally are closed. This is normally open. This is normally closed. Normally open so it is just loaded and 0000. But normally are closed mean load knot and 0000. Then out is a P0064. So this is for the input system. And therefore this is for the memory system. This is the OR system. OR system. Step 1 and step 2. Step 1 and step 2. After step 1 is step 2 will operate. In this case, step 1 we write at the up and the step 2 we write at the bottom. The next one is the step 1 and step 2 are connected as the AND gate. So in this case, what you do is load and 0000 and 001 and not and 0002. Out is P0064. So this is this one, and this one are connected in series, and then all the operation will impact on the output. So this is these are examples are letter diagram. The next one is everything is this is the AND gate represented. This is a step 1 and step 2 are kind of program letter diagram. So this one represents step 1 is 0 line, step 2 is a 2 line. Here is a AND gate system. Here will be the OR. OR means this one and 0000 and 0001 and 0002. Either operation, one of the operation will output the relay one. So the how to write is 0000 load and 0000 or and 0001 or not, because this is NOR gate and 0002. Then out is a B0064. So this is a letter diagram, this is a program. So that we can write the this is our memory program, and this is the letter diagram, this is the program, and this is the letter diagram, this is the program, this is the letter diagram. So this is the way we write the basic writing principle. Also that you also see the thing. So in this case, this and this one are connected to the AND system. So the load and 0000 and 0001 and load and 0002 and 0003. So this is the load. After that, these two are similar to this OR gate. Therefore, the OR load. This is it. This one or this one we are OR load, and the out is a B0064. So this means that N0000 and N0001 are AND system, N0002 and N003 are AND, and the N0000 and 0001 and N0002 and N003 are OR. So this is the 2 AND and 2 OR system. 2 AND gate, and both two are connected in the OR system. The output will be there. Output is this is the function. So this is the way we write. So this is for the letter diagram. This is the program. So that this is all the basis of programming system for the PLC, and we use a PLC simulation software, Logic Pro. We use a Logic Pro. Use a PLC simulation software. So the Logic Pro is a logic system. So the Logic Pro. So Logic Pro system is here. Logic Pro screen. So this is a Logic Pro screen. In this case, you can put the switch, or you can put the relay, coil, input output devices. So we copy and the input output devices we can write as a PLC program. Because of that, when you write a PLC program, we need to write the switch. So that therefore that we have to provide with the this Logic Pro system. The Logic Pro we can simply add the those bins. So we also need to edit the program. We have to click the function and you can edit it. So you can edit, you can put the and these are their characteristics you can change. So this is a debugging system. So that we also read through the Logic Pro documentation. Logic Pro documentation you can also are also included. So that this is the kind of the PLC program we can put the logic flow and the end. So this is a simulator system, input-output simulator system. So when you write the program by using a logic flow, it can come in line like this. And here is a simulator system, input-output simulator. Input-output simulator means that the function of the circuit can be output input can be coming out. So this is input-output simulator system. So this is the kind of the logic flow circuit we draw. And also relay we can put like this. Okay, this is what we talking about this. After that, you can test the program. You test the program, we can operate, and whether row release, row output function lights are coming out or not, we can use the lights. So this is where PLCs are programming are basic. So that based on this PLC programming basic, you also do this sample exercise. So this is the PLC's nodes. Copy the PLC nodes programming with a logic controller. And those are logic controller PLC function. You have to read the PLC program. So you can see there's a typical PLC program. You can set up the PLC program. So now this one right there, how to set up the PLC one, you can read it. Then also you see the video. So this is the basic PLC's full diagram. You have to learn a PLC, and this is PLC. Also you also study the trilogies tutorial, PLC programming with the trilogies lesson, set and reset function, timer function, PLC simulator function, write the first PLC program function, and the counter function, shift register function, PLC instruction, and the PLC timer, and the PLC processor. So those are the video. Those videos you have to study how the PLCs are working. So that the site is here. You will also highlight computer.com. So I will give you the PLC. Programmable logic control. Firstly, you have to go to enter the site. You will also college.com. Select electrical trade 2022.htm. I joined the college.com / electrical trade 2022.htm. Then you have to go down, scroll down, and then you can see the programmable logic controller. Click the programmable logic controller. Then you go to the textbook. This textbooks are now I give you this textbook. Programmable logic controller training course. So this textbook. I teach you this textbook. Programmable logic controller training book. From this training book, I talking about the lecture. You have to read the page 45 to the page 75. So today's lesson cover the page 45 to 75. Here is page 45. Basic PLC operation, and then page 75. So this is for the PLC's system. How to write down the PLC system, editing the program. So page 75, 45 to 75. This is today's my lesson. Today my lesson, this is for the programming logic controller. In the meantime, you have to read this book. After that, you also do this read this lesson here. You have to download it. You have to set up a PLC program. This is all the links that you can get the required program, required instruction, also the PLC programming. This is for the lesson the PLC programming. Also, after that, you have to view the video. Basic PLC full lecture, learn the PLC, basic of the PLC, lesson 1 trilogies tutorial, PLC programming with the trilogies lesson 2, set and reset function, timer function, simulator function, first PLC program, counter, shift register, PLC instruction, PLC timer, and a PLC processor. Those things you also have to study. So this is for the today lesson, PLC part 1 lesson.